Okay. Hi, everybody. So this is your second practical session with me. Let me try to do something first. Okay. Okay. Not so familiar with MS Teams, but it's okay. Right. So for this week, we're going to continue our practical. I think we haven't covered all of the practical 1. Then after that, I will cover on practical 2. So practical 1, we will look into, for this week, we're going to look into the sci-fi recap. Okay, so I think you've already used this module for you to understand the data that is given to you and maybe do some manipulation or try to process your data so that it will give more insights, or it can help to complete your data by adding missing values if needed. Okay, right. Any questions? Because I have already posted exercise 1. Okay. Have you guys tried the exercise 1?
Yes.
Yes. Any issue? Easy? Hard?
Exercise 1 feels more like data cleaning stuff.
Yes. Data cleaning.
Oh,
And also, yeah, basically understanding the data and also understanding how to use some of the functions available in Python. So it's really about practice. Okay, so maybe I will share the exercise 1. Okay, so this is the exercise 1. So I'm gonna stop my camera so that I can reduce the bandwidth. Okay, right. So exercise 1 should cover all this. All these are very simple. Okay, so I think maybe it's also a recap on how to use very basic Python. Okay, how to use, how to replace strings, how to insert, not insert, but receive inputs, okay, using Python, because we can also do that in Python, just like C++ or C or any other programming languages. Okay, then let's say question 5. This one is also receiving inputs from users where you try to process identification numbers. So here you need to process the identification number to see if it's a valid IC format. Format only, yeah? It's not really about whether the number is giving information about, let's say, the location of the user, etc., because that will be maybe another level of verification. Okay, it's just only checking the format. Then number 6, I think this one is very simple. Okay, so it's a simple flowchart. Okay, you can maybe relate it to activity diagram. All right, so how do you implement this algorithm using Python codes? Okay, this is very simple. So 7 and 8 is very related to what we are doing in the practical 1. So if you have any issue in exercise 1, please let me know. Okay, we can discuss this later. Okay, so let me go to the SciPy part. So this is the SciPy recap we're going to go. So SciPy is basically module to process numerical data most of the time. Okay, most of the time it's related to processing numerical data. So we look into how we can use it for numerical integration. So for this one, we want to do some numerical integration for this equation, fx equals to x squared. And this integration is from the value 0 to 3. Okay, so you can actually perform this integration manually, but you can also do the integration using programming. Okay, not only Python, but also other languages. MATLAB can also help to do this. Very simple. Okay, so let's try to set this up first. Yeah, I'm gonna stop share for a while because I think setting this up is a bit tricky because I need to make sure you can see the slides at the same time. Look at my collab. So it's up to you whether you want to use collab or you want to use your Visual Studio Code. That's fine. Okay, so I hope you can see these two screens that I split. Okay. All right. So let's look at the one on the right side, which is the PDF document. Okay, so let's look at hands-on 16 first. So let's add the markdown cells. Okay, markdown cells means adding the text cells. Okay, so you can do this just to add this part. If you want to, you can do this. That's a good practice to add notes in your Python notebook. Okay, so that you can recall what it's about. So we're looking into doing this sci-fi. Okay, so let's look into running this. Oops, that one is, oh, okay. PII dot interpolation. I don't need this. This is not a section. Okay, yeah, we're done. Okay, this is not so nice. Hmm. I forgot how to do this. This one is not part of. Okay, never mind. Just ignore it like that. We're gonna do the two section. So let's go into coding. Okay, so to use the SciPy, of course, we have to import the SciPy function. All right. So if you initiate the AI tool, so you will look into, there are many suggestions given to you, but I switch it off because it's to teach, and with the AI tool, it's quite annoying. So let's leave it as it is, as we have over here. Then you can run this, wait until it is being installed for you. So if you're using Visual Studio Code, maybe sometimes this SciPy is not available in your machine, so you need to do a pip install. Probably you have to do a pip install to install the SciPy. When you use Collab, all these things are already ready for you, so you don't have to pip install. Some modules, Python modules, you do need to do a pip install on Google Colab, which means that they did not put it in their Google space. Okay, right. So now we want to define our function. So this one is where the part where you try to customize your function. Okay, right. So you can do it very simple. You can follow that way on the right side, or let's say you want to make it like, okay, I want to have it very explicit as written like this, where y is equals to x to the power of 2, and then you want to return y. Okay, so you can do it this way too. Right, so there's no issue when you run this. Then you add another line. It's good to separate it between when you build the functions and you run the functions. You can separate it. You can separate the cells so that you know which part you're supposed to look at if you have some bugs. Okay, I think you know all this. Right, so let's say we want to compute the definite integral from 0 to 3. So we can print the result. Okay, and also print the error if there's any, because this is a function which allows us to do that in SciPy. So we call SPI quad. So quad is a function, is a submodule of SciPy, and we bring in our function, okay, f, and then we insert our integral lower bound and also upper bound as it is, okay, and then just that. Then let's try to run this just in case we have some error. No error, so we can print the result of the result. If you want to, you just want to do like that, also can. Let's see what we have. So that is the value that we have over here. So this is very approximate. Yeah, it's very approximate in terms of the value. You can just get the value of 9, because when you look at this value, actually you can just round it up and you get a 9 value. Okay, if there's any error estimate, you can also print it out. Okay, you can print out another, let's say you just want to look at it over here, print error. I'm just going to do it this way. Oh, this print error, just want to see whether there's an error value. So the error value is very, very small over here, which you can actually ignore. Okay, so I'm just going to put it at overlay, something like that. Okay, so all right, so this is a simple version on running hands-on 16. You can do the same thing as you see over here as well. Print f is a standard way of printing some combination of strings and also variables. Okay, so you can insert your variable over here, result, okay, and also variable error. Okay, so now we're going to hands-on 17. So I think this one is quite simple to do. Okay, so let me try to minimize this first. Oops. Okay, so we are going to do some integration of exponential function. So if it's an exponential function, so you have to call the right function in Python to run the exponential function. And this exponential function is actually in the NumPy module. So we have to import NumPy again. Actually, I've already imported at the top part of this notebook, but I'm just going to import here because I don't want to run the one at the top. Okay, okay, sorry. It's good to clean up your codes once you have already completed this practical session, yeah, so that you don't have to call the modules many times within the same notebook. You should only call it only once. Okay, right. Now we want to compute that integration, but let's build our function first. So def, okay, where we insert the value of x. Okay, now let's say our y now is an exponential function. So we're going to use np. So np comes from the numpy, and we call exp. Okay, so there are various types of, I think, I can't remember what's exp2, but you can test it out. I think it's another exponential function. Right, so now we can insert the value negative x, and then we know this is a negative x to the power of 2, so put the double star here and put the value of 2. And then that's it. Then return y. So run this, see whether we have an issue. Okay, done. To another line. Now, this time we want to call it out. Okay, so I'm so lazy. I'm just going to copy the one at the top there. Okay, so call our function f. If let's say you call this as a g, then you should put this value f, replace the value f with g. Okay, so our lower boundary is -2, upper boundary is 2. Run this, okay, done. Then you can print the result. Okay, so that's the exact value, not approximate, sorry, exact value. Okay, and then you can also print out the error if you want to, like how we did over here. You can actually use this same line over here to print your both result and also error. So that's the simple way on how you can use SciPy to solve some mathematical equations. Okay, it will give you the exact value or sometimes approximate, depending on how complex the function is. Okay, now modify cosine hands-on. Oh, I forgot to change this. This is hands-on 16 to perform numerical integration of fx. So sometimes you have to also ensure that you know which module that you can actually use. For example, if NumPy covers a lot of like sci function, cosine function, so you use NumPy. Okay, so that's the part that you have to investigate sometimes. Okay, so the next one which you can actually do using SciPy is interpolation. So this is where sometimes you have a lot of data set. And you know there are maybe some trends of data which you collect maybe monthly, and they are in numerical form. Okay, so imagine that you have collection of some observation over here. You see here, if you look at this graph, it is a collection in hours. Okay, so from 0 to 5 hours. Then we have a collection of temperature. So temperature, you know that this is not in it can be in float numbers, so continuous numbers. Okay, so it is not integer. So if let's say you have missing values, so you want to know what happens in between these hours. You have 0 to 5 hours. So what happens in between 0 to 1 hour? What happens in between 1 to 2 hours? So you can do an estimation by doing this interpolation. So I think you know about this already. Okay, but interpolation is not suitable for the case of, let's say you have missing data related to that uses labels like positive, negative, etc. So you can't interpolate that. You can only interpolate numerical values. So you can also maybe interpolate some when there's a lot of data sparsity in the data set. Okay, so they are missing years that do not have any values. So you want to try to interpolate based on the previous data or based on the trends of data available in your collection. Okay, so you can do the interpolation. So if you see this graph, all right, so the one data points, the red color, are the ones that you have in your data set. So the estimated point is the one in blue. Okay, and if the trend is very, you can decide whether you should use linear interpolation or non-linear interpolation. You have to look at your data set. You have to observe your data set. Is there a trend that goes linearly, okay, going down, going up, or is it sinusoidal, or is it well, you look at maybe it looks like a quadratic trend, something like that. So you cannot use linear interpolation. So you have to be careful on that. Okay. So let's look at how to demonstrate this. Okay, this is just for demonstration. Maybe some of you have already used this. So I'm gonna run and do this code. Okay, so I've already import the SciPy module. I'm going to import again the matplotlib. Matplotlib. Okay. Dot pyplot. We're going to use simple pyplot. Okay. All right. So run that. You don't disturb that. That one is all the modules over there. Then here we are generating value. So you're not given any real data set except for your case studies. Okay. So this is a NumPy values. So it runs from 0, 1, 2, 3, 4, 5. So this is in time in hours. Okay, so you can do a comment here. Then you generate the Y values, also NP array format. So this is quite specific. Then, 10, 15, 20, 25, 30, and 40. Perfect. Okay. Right. So from here, you see that they are in pairs. 0 is paired with 10, 1 is paired with 15, and etc. So this is for temperature. Okay, run this. So you get your values. You can also print it out if you want to. You are curious, you want to see what is X. So print X. So those are the value of X. What is Y? Up to you. Always do a check. Okay. Right. So now let's look into how we can create the interpolation function. So we will use the submodules called interpolation 1D. So it's just a one-dimensional interpolation. So we call this variable as interpolation function, just like that. And then we call the spy.inter p1d. So we insert the data set. We have the x, and then we have the second one is y. And then we will use linear. Run. There's no, cannot be interp 1d. SPI. Didn't I run this just now? Oh, sorry. I was too eager to use that sci-fi. That's integrate. Sorry. You need to call out interpolate. Okay, interpolate submodule. Yeah. Okay, we import that and then we run this again. Okay. Clear on that part? All right. So now we've already done the interpolation function. Then we can use this model. So basically you are coming up with a model, interpolation function model. So it can change according to the data that you've already set over here. So you can try to change different X values and you can insert that X values or Y values, new X values or Y values into here, and then you get a different interpolation function. Okay, so next you want to estimate the temperature at a certain data point. So we are going to call the interpolation function, interfunction, and we're going to put what is the point that we are curious. So you can run any value between 0 to 5. Okay. So let's say you want to check what is the estimated, 0 to 5 hours, not talking about the temperature here. So you want to estimate the temperature based on that particular data point. So let's try to print the estimated temperature. Run that. So you get 22.5. So if you change this value, let's say 3, then you get a different value. Let's say you want to do something 5.5, then you get an error because your X values, okay, which was used to do the interpolation function or to build your model, is only up to the value of 5. So you can't interpolate any data points that is above those values. So it should be within the data given to you. So you have to be very careful on that. Okay, so let's say we estimate for 1.5 hours. So you have that estimated temperature. Now to plot, I think this part is quite simple to do, straightforward over here, but let's try to plot. So we use our module matplot just now, which is the matplotlib submodule. Mana tadi ya? PyPlot. Okay, so we're going to use PyPlot. So let's say we're going to do a scatter plot. Okay, so insert our XY value. Yeah, let's do that first. Later on, we label it. We just want to plot the values first, the data point. So we insert the XY value. Yeah, this is to plot the line. Line style here is equals to dash dash. Up to you what pattern you want, maybe dash star or whatever. Okay, so this is the label for linear interpolation. To see our interpolation interpolation on the graph itself. Okay, then we plot another scatter plot for the interpolated value, which is the estimated temperature tadi. So here we have the point that of concern is 1.5. If you want to do this as a variable, you can do that as well. Let's say this is about hours, which hour that you are interested. So this is 1.5. So we're going to change this as 1.5. Run this. Oh, salah. Hour. Sorry. Okay. Now we change this to the same variable hour so that it will be more dynamic. Okay. Then we have the estimated temp, comma, color. This one takes time actually. I prefer to do this using the AI because yeah, why not, right? Okay, never mind. Let me type this. Estimated one. Okay, now we're gonna do the plot label, X label. Okay, this will be in time. Then another plot label for X, Y. So this will be temperature. This will be in degrees. Okay. Then plt dot legend, which means I have to also complete the one at the top. But okay. Okay, so I have to complete this one because I have the legend there. Label here will be data points. Okay. Run and hopefully there's no problem. Okay, looks like okay. Okay, so we have data points here, and then the blue color is the estimated point at 1.5. Okay, so this is at 1.5. Let's say you change this hour to be 2, run this again, and then plot it again, then you have different estimated point. Okay, if you want to keep this image, you can also right click this and save the image as it is. You can download it and put it into your report. Okay, so this is very nice graph generated by matplotlib. All right, so yeah, that's the part where you can do interpolation using SciPy. So far for as of now, you can do interpolation using linear interpolation. Okay, because I don't want to go into detail about interpolation, etc. We have other serious matters related to AI. Okay, so but if you already know how to use other type of interpolation function, yeah, okay, by all means you can actually do that. So yeah, so that's wrapping up the SciPy. So you know that SciPy is useful for numerical integration, and it helps to estimate missing data in real-world applications. So when you have data set, as I mentioned just now, missing data, missing numerical values on certain data points, especially when you don't have enough data set collected by certain people. Maybe this year they collect, next year they don't collect. So you have to do something over that. Maybe some of you would feel that, oh, why not you just use AI to estimate it, you know, but that is not objective. Okay, it's not an objective method to do. We need to have maybe more precise way to do it, and we know the interpolation function can actually help us to do that. Okay, so use mathematical way on how to insert or add the missing values in your data. Then you build an AI model, not predicting the values using AI, and then you use that data set, which you've already predicted using AI, to build another AI model. It doesn't work that way. It's wrong. Because why? You are predicting. Prediction is not correct. So it's still a 50-50 chance. It is correct. It is not correct. So you have to look at what would be the best way to help your missing data issue. Okay, if you really can't solve the missing data issue, maybe you have to drop the data if it's not that important. So there are ways on how to handle and prepare data before you go into AI modeling. Okay, do not predict your data before you use it for AI modeling. That's a no-no. Okay, all right. So besides that, we also look into how we can visualize to understand your data set. Okay, maybe it can also use to help you to see whether your data is in balance. Okay, we have more positive labels compared to negative labels, and maybe too imbalanced clustering. Maybe you look at there are too many red clusters compared to blue clusters, etc. So you will see this maybe after you do some more research when you want to do AI modeling. Okay. Okay, so exercise 1 is related to the Python recap. So we'll look into this later. Yeah, I would prefer to look at your work, but maybe I have not done the submission box for you to upload the exercise 1, but I'll do this one later today. And if you have time, we can discuss the questions. So for practical 1, is there any issue you want to discuss before we go into practical 2? Any questions? I guess there's no question. Very easy, yeah? Okay, let's go into practical 2. Okay, so practical 2, not yet AI. This is still about data. Why I emphasize on data is that when you want to do AI or AI modeling or AI prediction, you have to make sure your data that you use to do this prediction, or you want to fine-tune your data using some pre-trained model, you have to ensure your data is ready to be fine-tuned. It is clean, it is safe to use, etc. Because your model performance it really relies on how your data is, the condition of the data. Okay, especially when you have a data set that you do not know about, you did not collect the data, but maybe your boss gave you the data, and then your boss says, okay, I want you to do prediction using this data. You have to know about your data. It's like you're supposed to build, you want to create a recipe to make some food. Before you get to that food, you have to understand your ingredients. Do you have enough ingredients? Are your ingredients clean? Is it the right ingredients, and etc. So it's the same thing. Okay. If you look into that angle. So we look into data cleaning for AI experiment. We're still looking at data cleaning. So this is my basically what based on my experience when we deal about data before we go into modeling. Okay, so let's say you have a data set comes from a corpus. Okay, so a corpus is equivalent to data. So some people use multiple data sets, so we call it corpora. Okay, so let's say you have a corpus A. Corpus A can contain only text, only images, some voice or some sounds. So we are using this to do AI modeling or training. But before that, you have to ensure you have gone through some of these stages. So you have your data set and you know it is dirty, okay? It can be text documents, it can be sounds, it can be signals, it can be anything, it can be images. So what I'm trying to tell you, anything digital can be trained for AI, multiple ways, okay? So you have to inspect your data set. You load it up into your workspace, okay? And then you kind of like, you have to do some observation, inspection, display the data to understand more. If you're using speech, for example, speech sounds or any sounds, you have to know what is the sample rate, sample beat, okay? What is the length of the sounds? Because when you do AI modeling, if the sounds are too long, sometimes the model cannot be used to model a sound. You have to know what is the sample rate, sample beat, and also the length, the frames, the speech frames, the audio frames that you can use to train a model. Same case as text as well. You have to know how many tokens that you can actually insert if you want to train a language model. You can't give a whole book of text, let's say it's a digital book, and put it into a language model to train. You just cannot do that. You have to do some data manipulation. You have to clean it. You have to pre-process it. You have to do some feature engineering. So these are the processes that you need to go through. So before you go into AI modeling, the hardest part will be the data science part. So this is the thing that you have to know prior to do AI modeling. Some people feel like doing AI modeling is easy. Yeah, before you do the data cleaning, it is easy. Because if the data is very clean, it is ready for you to model, things will be very easy because the model is already ready for you to use. The codes are ready for you to use. But if your data is not correctly done, you can't build your model. Okay, so it's good to understand the models, do some simple analysis, do some visuals, do some maybe class distribution analysis so that you understand whether your data is suitable for you to do modeling or not. Okay, so the rest of the part over here, we're doing data cleaning, pre-processing. All this will be explained later. The next part, the ultimate goal is to have some features that are ready to be used for data modeling. Okay, maybe when you do data modeling or AI modeling, you don't see this feature engineering part because sometimes it is embedded into the modeling technique itself. But it's good to know there are how to say, there is a process involved here, which is called feature engineering. Okay. Yeah, because feature engineering, it helps the AI model to work efficiently, especially when the data is huge. So they need to extract some important features only, not use the whole data set, but important features only to be used for modeling speech or modeling maybe image classifier or modeling sentiment classifiers. So feature engineering is important. Okay. All right. So let's go into that. So the practical part here is to give you some hands-on on certain case studies. So I'm only focusing on using textual data related to sentiment classification, which I will use throughout here lah. I hope I can add more case study Maybe some of you are interested to do about language modeling. So that's a different case study. So I'm focusing on sentiment modeling because the approach is still the same. Okay, if you use this way, if you using different case study, let's say image classifier, text classifier, what summary classifier, chatbot, apa nama ni, chatbot modeling kah, it's the same thing. You have to make sure you have to you prepare your data properly. Okay, right. Then, yeah, the objective is to explore some data cleaning techniques and also apply feature engineering technique to transform data for AI modeling. So the ones that I show today is going to look into some, advanced cleaning and also feature engineering and also a continuation on basic cleaning again. Okay, so let's go into the data cleaning over here. So why we want to do data cleaning? What is data cleaning? So this is the process of identifying and correcting the errors. Okay, if you found any errors, inconsistency, inaccuracies in the data set, there are a lot of HTML tags, there are a lot of emojis which you do not know how to interpret the emojis in your model. So you need to improve the quality and also the reliability of the data for model training and also maybe for analysis. So importance of data pre-processing for AI experiments is that raw data, especially when you just collected it, contains a lot of errors. Maybe there are some duplicates. Okay, so you need to improve this so that the performance of your machine learning model is good. Okay, right. So these are the list of common issues in text data that I have gone through in my research and also in when I discuss with my students when it comes to machine learning training. So these are the things that occur. So, but this is not limited to this kind of issues. There will be many more issues, especially if you deal with text data that are not commonly written in English. Maybe there are some slangs inserted. So if you need to remove the slangs, you remove the slangs. But if you want to consider the slangs, then you have to do something else. Okay. All right. Before we go into practical, so as I mentioned, the one on the right side, these are the common issues. So I want you to read this in about 2 minutes, and then I want you to identify, based on my questions later on in the next slides, what category is this issue. Okay, so we have missing data, stop words. So stop words means that in English context, English sentences, for example, these English sentences now. So stop words are like is, the, of, and, in, it's, for, also we have and here, of, what else? And other things. Stop words are the words that are very commonly found as a conjunction, as a word to be used at the beginning of a sentence, and these are meaningless in the context form. Even though in English sentence we need to use them, it's very important, or else we have grammatical error or grammatical mistakes when we write essay, for example. But if you want to do AI modeling, stop words are not necessary. We just want the real context out of it. For example, what is important, what is already an like trying to say it is a type of questioning type of word. Data, we know this is talking about data. Cleaning, we know this is a context of clean. So these are the context that we want to keep. We don't care about stop words. Okay, so spelling errors, I think you know about this. Okay, abbreviations and slang. So abbreviations like doctor, DR, maybe what else? CS, computational science. So all these may need to be converted into full form so that you have computational science, especially when we are doing speech recognition. We have to make sure that these are being spelled out. Computational science, not only CS, because if we listen to the speech, maybe that person did pronounced computational science, but in the text transcript, it is only mentioned CS. So we have to follow how the speech transcripts, the speech sounds like in the transcript. So all these things are very important. Other things like special characters and emojis, non-ASCII or Unicode characters, I think you understand what does this mean, okay? And a class imbalance, maybe too many positive labels and other data encoding issues. Okay, right. So first question here, let's say on this left side, you have a data set that has 3 lines of sentences, and this contains the entries for customer feedback. What do you think the primary issue with this text data?
Duplicate.
Duplicate, yes, but that's not the primary issue. What else? Okay, Rebecca says lower uppercase. Yes, inconsistent of use of lower uppercase. So duplicate, yes, it is an issue, but the most important thing that you have to settle before you remove the duplicates, you have to turn this text data into one case only. Either you want it to be all uppercase or you want it to be all lowercase, because programming, as you know, they are very sensitive about this case. So most of the time, we have to turn the text data into lowercase, okay? Because it will be easy for us to identify whether is it a stop word or is it not a stop word, okay? Second question, this data set includes the following entry. What is the primary issue in this text data?
Emoji.
Yeah, good. Very good. Emoji. As I mentioned just now, most of the time we can't handle emoji in AI modeling. So you can remove it. Okay. Also, over there we have hashtags. So hashtags, when it comes to AI modeling, we also ignore it. We can remove the word that is attached to the hashtag. We can remove it. It doesn't bring any important meaning. The most important thing is the sentence in the social media post. Okay, good. Next, left side, we have online review contains this following entry. What is the primary issue?
Spelling errors.
Yeah, good. Okay, spelling error. We have this problem, recommend. It looks correct, but it's not. Okay, right side. It's not really about the text data itself, but the last one here. The data set contains 90% positive reviews, only 10% negative reviews. Good, class imbalance, good.
Yes.
Okay, yeah. So this is the thing that you have to consider before you start to do AI modeling. There's a class imbalance issue. An AI model should not be biased. So you have to ensure that you should try your best to come up with an AI model that is fair. So fairness is very important so that it will cover everybody's reviews, you know, opinions and etc. Okay, so this is imbalance. So how do we deal with this? So there are some techniques involved to deal with imbalanced data for textual data. Okay, for textual data. Okay, so let's go into.
Sorry, madam.
Yes.
Someone asked how much can we say it's fair?
How much is fair? We should achieve 50-50. 50% positive labels, 50% negative labels. If we have neutral labels involved in the sentiment data set, then we have to have the equivalent of 33% equivalent to, I think 33%, yeah, 33.33% of positive, 33.33% of negative, 33.33% of neutral. So that's how you should achieve your data set. But there is an automated way on how we can actually do to solve this imbalance issue for textual data. Yeah, thank you for the question. Okay, so let's go into this hands-on. Maybe you can get ready your workspace if you have not. Okay, so here we want to inspect the IMDb dataset. Okay, I forgot to share about this one. So go to the edit cost page. Okay, so if you go course info and resources, you have data sets here. So go into these data sets and download the IMDb dataset version small. I have the full version. I put in the Teams, but we're going to use the small first because this is a special one that I created for this practical. So prepare your workspace and then we will start in 2 minutes. Okay, I'm back. Sorry for toilet break just now. If there's any question, you can repeat it again. Okay, going to change my screen. Yep, yeah. Okay, so if you already downloaded the IMDb, very small data set over there, make sure you've already uploaded into your G Drive as well, or in your local machine if you are using your VS Code. So you can connect to your G Drive to upload it into your G Drive folder. Oops. What did I do? Going back up. Wrong. Wrong one. Okay, go to home. I think it's content. Yeah, content. Go to Drive, My Drive, and you can go to your folder. So I put mine already, data set over here. So this is the IMDb data set. So you should open it up to look at how it looks like. You can double click and maybe I put it over here. Then you will see this is the data set that you have over here. If you're using Workspace, you can see this, collab Workspace. If you can see this on the right side, okay, so this is your data. I think there are 1,000 plus data set over here. Data set. Reviews, okay. So if you see here, they're not in a one-line form. That's fine. Sometimes sentiment modeling, they allow one review, one label, or they allow one sentence, one review. So you will see different types of data set. It depends on how people actually use them for sentiment modeling. But this data is not ready for sentiment modeling, I would say, because we need to do some data cleaning. Okay, so we're going to do this today in this session. So you can close this up. So we need to load this into our space. Okay, we can start to code. So we call this for reading data set. Okay. But this is assumption. Okay, so let's write to our data set. So of course we need to import Panda. ED. Oops. You can use whatever name you want to. So import that. Add another line. Maybe we close this. So we need to open this because we need to know where the path of the data set. Okay, so now we want to load the data set. So loading, maybe we call this as df as the variable to load, and then we call the PD, and this is a CSV file. So there's a function under pandas. So you can just use the submodules read underscore CSV. Here we need to know what is the path to the data. So you can right click on this, copy the path, paste it here, and then click on enter. So you have the path to your data set as it is. Jadi, you can run this and see whether it works. Okay, then we close this so that we have more space to see the codes. Okay. Right. Now, let's say you want to display some parts of the code, not the code, sorry. Some parts of the data using this Panda. So you can use df.head. So it will display the first 5. If you want to display the next, the first 10, you can change this value inside here to be 10, 100, and etc. You can click on this if you want this to have some interactive table. You want to see it interactively. Maybe this one is not so full, and you can click on this. Then you will see all the data set over here. Okay. So let's leave it as it is. If you don't want to see it, then you can clear the selected outputs, or you can hide the output. Let's say we hide it first. Later we show it again. So the next part is to process it. Okay, so the structure should be something like this. All right. So let's try to understand a little bit about this data set. Let me try to make this as a full screen over here. In the CSV file, we only have 2 columns. One is the review, the first column. Second column will be the sentiment labels. So assuming that this data set has the correct sentiment, so it is done manually by someone else. Okay, maybe they read the sentence over here, all the sentences, the reviews of the person, then they give the sentiment label as positive. So we need to see how many labels do you see over here. So there's positive, negative, maybe it's only positive and negative, who knows? So, but you can actually process this data frame to calculate how many positive labels, how many negative labels automatically. You can do that. Okay, you can try to learn how to code that in Python. So the most important thing that you need to understand that this is an English data set. English data set, maybe there are some not familiar words. Probably these are the names of the movies because this is a movie data review. Okay, movie data review. So fine. This is based on your observation for the first time. Right. So now let's go into the other hands-on. Let's see what we're supposed to do. Okay. Now we are going to basic cleaning technique first. Most important, I would say one of the most important one. When you deal with textual data to clean, we have this module called regular expression, or in short, we call it as regex. So the module in Python is called RE. Very simple. You just import RE, and then under RE, there's a lot of functions on what you want to search, what you want to replace, what word you want to convert into something else. You know, you want to process the textual data. So I suggest that you read about this if you are interested into cleaning textual data. So what is a regular expression? It means that we are looking at a sequence of characters that you can actually define a search pattern. Whereby maybe you look at when you have some sentences with let's say sentences that have a mixture of patterns related to genetic algorithm. You have the GA. So you can actually learn that, and then maybe you can identify the same pattern on other textual data. So these are the things that regular expression can do. It can be used for text validation, searching, and of course data cleaning. And I have a link here whereby you can look into the full documentation on what is regular expression. So on the right side over here, there's an example on how we can demonstrate on how to use this regular expression, RE. So let's try to do that as a practice before we move forward to process this data. So I'm going to hide this first. Our next part is on practicing the regular expression. Oops. Okay. So we import RE, run this, and then let's say we are given some strings of sentence. Okay. So here we have the price is $50. Okay. So this is our text. Then let's say you want to see from this sentence automatically find the digits or the numbers. So based on our own observation, of course, this is the number, but we want to do this computationally. Okay, so let's try to search that throughout the sentence itself. So let's try to match it. So I call this match 1 as a variable because we're going to do some matching other practice later. So we call RE, and under RE there's many type of many functions available. So we're going to use search. So we search for the numbers or the digits here. So we call R. R is a row string notation. As I mentioned here in the practice here, it's a row string notation. So please use this every time if you want to search a particular character in your data set. So then after that, you open up the double quotes, then \d. So \d means you want to look at digits, and then you want to find the other digits next to it. Maybe it's the length of 2, length of 3. As long as the next the next character is a digit, you want to take it out. Okay. So bring in the sentence, which is the variable text study at the top there. And then we want to print. So we call the match variable, but we only want to print out the output. So we have to call out group. Later on, I'll show you what's the difference between not calling group and calling the group. So run this, so you have the 50. Okay, so let's say your text has 500. Then you run that, then you have a 500. But let's say you have a space here and then you have 1,000 like this, 500,000, run this, and we only take the first 3 digits at the front because the next part over here is a space. So the next part of that is not, after that 500 is not a digit, so it will not read it. So there's other ways you need to do on how to make sure that the whole digit is being taken. That's where you have to do data cleaning. Either you have to do it manually or you do it computationally. So you have to do some research on that part. So let's say this is your digit that you want to detect. Let's say you only want to use match 1 like that. You want to print it out. So it will give you various outputs over here. Okay. Here is the position or the index of the sentence itself. At the start of 14 to 20, it found out that the search function found out that we have digits. Okay, so this is the I would say index lah. Okay, index 14 to 20, but we don't need that. We just want the value, so we call group. Okay, so this is when you use the search submodule under regular expression. All right, so there are other ways to do searching patterns or identifying patterns or substituting patterns, etc. So let's test that. Here we have done for search. Let's say we want to do for find all. Let's say you want to find all digits and print it out. So we call this as match2 equals to re dot find all. So we call that submodule. And again, we bring down the raw notation, string notation over there. Then we want to search for all digits available in that text, comma, and then we bring text variable. Okay, run that and then try to print match 2. Okay. All right. So doing this, you can get that match 2. So when using find all, it's not the same as how you did for search, yeah? So there's an inconsistency a bit about this regular expression module. So sometimes you need to use the group, sometimes you don't. So when you use find all, you don't need to print the based on the group. Just use match 2. Okay, so this is similar to what you have at the top there. So it really depends on your center, how you want to use the search function. So let's say I'm going to change a little bit over here, do another text sentence and see what happens. Oops, and $20. Okay, let's say this is text 2. This is text 2. When you use find all, it will find all the digits available in the text. But for search, it will not do the same thing. You can try this later. Okay, using this same sample of sentence. Okay, so there's a difference between using find all and also search. Okay, if you want to use substitution, you use re dot SUB. So let's say you want to replace the $sign with RM. So you can do that. So match 3 equals to re.sub. You replace that. So what will be the pattern that you want to replace? So let's put that as R, and the replacement would be, or before that, we want to identify the pattern. Sorry, identify the pattern. So you put a slash, a backslash, and a $sign. I'll tell you why you need to use the backslash. Let me complete this first. So the replacement will be RM. Then the variable that we want to look at is the text2. Let's try to use text2 first. Then you print match 3. Okay, so printing this will print out the same sentence again, and we see that the replacement of the $sign has worked. So let's say you forgot about the backslash. So a $sign, as it is like this means that you are looking at end of a sentence. In Python, we use $sign to indicate end of a sentence. And I just do it here, but I won't run it. And this sign, the hat sign. This sign indicates start of a line. Start of a line of a sentence. Okay. If you use this, end of a line. I think it's the same for other programming language. I can't remember. Okay, so if you do it this way, it will not detect the $sign. Instead, it will replace at the end of the line, replace RM. So you have to understand the regular expression carefully. If let's say this is not what I want, you refer to the Python on the Python documentation on regular expressions, so that you know what you want to convert, to change, to substitute, to find, and etc. Okay, so this is this is one sentence that you want to clean. What if you have thousands of lines of data that you need to clean? Of course, you have to do it computationally because we are lazy. We don't want to do the manual labor to go through of the sentence. That's where computer science comes in. You want to reduce the manual labor process. Okay, being lazy sometimes is good. Okay, right. So you can also test on the split. Okay, this one is interesting as well. At some point, maybe your AI model only looks at sentence by sentence to train a model. So you have to know how to split an essay, for example, or the data set that you have over here just now. These are in paragraph. Definitely this review is in paragraph. And let's say your AI models want you to process wants you to prepare the data for training, and that data must be in line by line concept. So you have to prepare it. So let's say you have thousands of this. How are you going to do that? Okay, I'm not going to do that myself. No way. Okay, so let's try to do that automatically. Let's say you have a sentence. I bring this down text2. Rename this as text3. And then you say something like this. $40 full stop. Then you want to split it into two sentences, because this is obviously, when you read this, you know this is a two sentences type of variable. So you want to split it as you see there's a stop label here or something like that. Okay, right. So we're going to use that to that dot split there to split your text into two sentences. Okay, so let's try to do a match number 4 for RE split, and then we have to initiate the what is the criteria to split this. Let's say I want to split it in two sentences. So let's try this with a dot label there, and then comma. Oh, we have to put the R here, forgot. And this is the text tree. Let's try this. Oh, what to bring? Ah, what did I do? I say backslash. Ah, okay, so that's a difference. So when you then don't have the backslash, so backslash is important at certain characters, yeah. So because if this is a dot, it means something. I can't remember what is it. If anybody has been doing textual data processing, maybe you can explain as well. So we have a backslash dot here, which means that whenever we see there's a dot there or a stop label, then we will cut it. So over here we have this. The price is $520. I will be given $40. So we cut over there as well. So there's a second sentence here. Okay. So if there's something else that is being cut over here, probably I think because it detects the end of the line as well. So we can actually split this properly if we have the right regular expression. You can also split it in terms of word by word. Okay, so word by word is quite easy to do. I think we can just do this way. Okay, maybe by space. Or maybe this way. Missing. Okay. I tried to do something different. If you want to split it word by word, this is the easiest way. I thought I can do it that way just now. We call text tree. Text tree is the variable. Sorry, text tree is the sentence that you want to split. And then we try to split it just like that. So in here, actually, you can put your parameters as well in the split function. Okay, but if you don't put it, so it will immediately split it based on the understanding that you want to split word by word. So word here, sorry, no, word by word, token by token. So here we have one token, the price is, and then this is considered as one token, and this is one token, and this is another token. So we can also, yeah, maybe I want to print out what is the length of the token. Hope it works. 11. So this is the length of the token. So sometimes, let's say language model says, oh, we only accept 132 tokens. Oh, only 300 tokens. So you have to know what is the length of the sentence. So if the length of the sentence is more than 300 tokens, you have to do a split, or you have to remove the last remaining words in the sentence if it's not meaningful. So this is the thing that you have to know. What is the length of the token? Tokens doesn't mean word by word per se. It really depends on how it is being calculated by Python based on the length of the sentence and etc. Okay, so these things are very important. Okay, so this is by using regular expression. So the next one is looking into natural language processing toolkit. Here I emphasize on NLTK. So I think some of you maybe use this NLTK for text processing already. So this NLTK toolkit has been was developed by a linguistics professor from Australia, Stephen Bird. I've met him before in one of the conferences that I attended during my PhD. Very nice guy. Yeah, he's still doing some NLP research, but he's more into community work on how to help with Aboriginal languages and etc. So he worked together with his student to come up with this NLTK module in Python. So it has been used for processing and analyzing text or human language data. It also helps you to tokenize the sentences. It also can be used for stemming, lemmatization. So all these terms are available under the umbrella of natural language processing. it can help you to prepare data for AI modeling, analysis, and etc. It also supports some popular languages. Unfortunately, it doesn't support Malay language, so there is the limitation of this NLTK toolkit. But if your text data is covering most of these popular languages, then go ahead, you can use this NLTK toolkit. So how to use them? You can import the NLTK just like that. Import NLTK. Maybe you have to also pip install this in your machine before you use this NLTK. Then from the NLTK, you have to know what you want to use. If you want to do tokenization, you have to call tokenize. And inside this tokenize, there are also other submodules in the tokenize submodule. So there's a lot of functions available in this NLTK. So run this. Okay. Then after that is not enough. You need to also download the data set. So this is to use the to process data to remove punctuations. So the data set is called punct_tab. I used punct, but it did not help. I don't know why. So I received some what do you call it, error message. So apparently we have to use punct_tab. I think it depends on the version. Okay, so if you use punct and it's okay, then you can download it. Oh, hold on a while. Maybe I didn't run this. Not found. That's funny. Let's try punct, because I did try to use this before. Not found in index. Punct, my God, some T. Okay, so it's downloading and unzipping. So you should only do this once. Okay, only run this once because this is a data and it's being stored in your workspace. Maybe you can also see whether in your local machine you have downloaded the data. Okay, so we have some sample text here in English and also French. So let's try to do some tokenization, which means you want to explicitly get the tokens out of that sentence. So which I will do only one, which is the English one. Okay, then you can do the French one if you want to. Natural language processing is amazing. Okay, because the punctuation, the punctuation data set has those several languages, so it understands English and French, or maybe Spanish and another language that is being supported by NLTK. So let's say that is your text, then you want to token it. So run. So that's fine. Now let's try to print the tokens. Okay. So we call this print English tokens, comma, tokens, underscore, yeah. Hold a variable, print it out, then you have your tokens. So this is similar to what you see in splitting, but let's say you are heavily going to use your NLTK. Why not just use the NLTK to process your data for tokenization, etc. But if you need to explicitly process based on regular expression, then you use the RE. So these two modules are sometimes being used together. It really depends on how you want to clean your data. Okay. Now, let's go into hands-on tool. Okay, right. So these are the things we need to do on the IMDb dataset. Convert to lowercase, remove punctuation, and also numbers and stop words. Okay, so follow these steps. Import the necessary libraries. Okay, download stop words from NLTK. Set the stop words to English because our data set is English. then build a function to clean the text. So build this function to clean the text. So for the cleaning part, I've listed down here. These are the things that we need to clean. Convert to lowercase, remove the number, stop words, and also remove the HTML text. Why we want to remove HTML text? If you see over here, you will see that we have that HTML text over here. That it won't be enough if we explicitly identify the pattern. You know, the sign over here, backslash, and then the BR, and then you have many, you see. So this is an obvious HTML tag. So in order to do this, to remove the HTML tags, we can use Beautiful Soup module. So this is another Python module to process data set. So I want to use that because they'll be quick. Okay. So let's move on to hands-on 2. Why is this here? Okay, I'm going to move this down. Oops. Move down, 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 down. So let's look into data cleaning. Okay, so the expected output is like this. Let's say you have a sentence on the left side will be the original, then you want to clean it up to become something that is like on the right side. It seems like on the right side doesn't mean doesn't give you a full English sentence. That's fine, because in AI modeling you want to model the context, not the grammar, unless let's say the AI model requires some grammar rule. Then you have to include those full sentence without removing stop words and etc. I'll look into that kind of use case if I have the time. Okay, but now we're looking at sentiment analysis, because this is a sentiment data set. So sentiment only looks at the context. Okay. All right, so we need to import necessary libraries. Okay, let's look into that. I've already import RE, already import NLTK. Now we need to import the stop words. So from NLTK.corpus, under here we have stop words. Import stop words. Yeah, there is. We click on that. And after we import that, we need to download the stop words. Okay, so we download that. So only do this once. Like you initiate the import of the Python library, only do it once. So we want to set the stop words to English. So we call stop words, stop underscore words as our variable. We can call it anything. So to set the stop words, we call stop words and dot words, if I'm saying good. Yeah. And here we set it to English. If you want Spanish, then you write that as Spanish. So this is our stop words. Okay. So no issue. If you want to see what are the list of the stop words, you can also do that. Okay. You run that, and then you see these are the stop words. So you see that these are the not really necessary being used in some AI modeling. Kund, other, she, but, she's, was, am, there, and it doesn't give any meaning in terms of the context. So we want to remove this. This is good if you want to have a good model that can help to predict good grammar structure of words. Maybe language modeling require this. Let me check that. Okay. But for sentiment classification, other types of classification, maybe sometimes stop words are not important. So you really need to read the requirement of AI modeling. Whether do you need stop words or not, whether you have to remove them or not. But for sentiment classification, you don't need it. Okay, right. So once we set the stop words to English, maybe I hide this. The next part is to create a function for cleaning. So first, just now, I think I forgot to import the beautiful soup. So you can search for beautiful soup module. So to import it, we call it as BS4. It's a beautiful soup version 4, and we import beautiful soup. There are many things you can do with this beautiful soup. If I have time, then I'll show you. Okay, but for now, we're gonna do this as a way to do data cleaning, especially to remove HTML tags. This is very good, especially if you want to clean data set that contains a lot of types of HTML tags. Okay, so let's build our function. Again, we use this def. So I call this as clean text function, and my input will be text. So over here, we look at what are the things that you're supposed to do. First, convert to lowercase. So converting to lowercase, you can just use the lower function that is available in Python. Oops, no, like this. I think it's not under regular expression. So what is happening is that I want to convert the text, and then after I convert it, I keep it in the same text. Okay, so the variable is being replaced at each time. So this is the first step, to change it to lowercase. The next one is to remove the numbers. So I think we've done this just now at the top there. We can use the regular expression sub function. So the pattern here is to remove digits, any digits that we can find. Okay, D plus, comma, and replace it with some empty space, and then we refer to the text variable. The next one that we want to do is to remove stop words. Okay, so to remove stop words, this one is quite complex. We have to use I think from the practical one, we have referred to line comprehension, if I'm mistaken. Oh, sorry, list comprehension. List comprehension technique. So we're going to use this to check for every word in the text variable, and to see whether that word is a stop word or not. If it's not a stop word, then we leave it as it is. If it's a stop word, then we will remove. Okay, so the line that we're going to use is we're going to use here we're going to use a join function. This join function is being used to join back the words, and then the list comprehension is being done inside this join function. So we will read if it's a word, then we need to check whether the word is a stop word or not. But for each word, we need to split it into tokens. So we use the split function. Okay, so if this word is not in stop words, then we will keep it. If it is in stop words, then we will not keep it. So we have that if else condition there, and not in is also a logical condition. So this is the join function to join back the word into one whole text again. So you will see this data how it works. Okay. The next one is to remove the HTML. So we will call the beautiful soup function and bring in the text as an input. Okay, so in beautiful soup, there are many ways on how to use this function to clean data set, but we want to be specific to HTML parsing. So we only remove the HTML text by parsing it out. So we detect the HTML text. I think it's quite easy to detect this HTML text. Then we will call this get underscore text function that is available in beautiful soup. Okay, So that is to remove the HTML text. The next one is to remove punctuations. So we have already downloaded punctuation list, but if let's say, this is to remove the punctuations as in this exclamation marks, stop values, etc. Okay, so we can actually do that. Okay, so text is equals to using the substitute function r.sub. We bring down the raw data notation over there. So for any punctuations, we can remove that. So we can set our rule at the start of, so we read at the start of the sentence until the end of the sentence. If there's any punctuations, you can use this pattern to remove the punctuations. Comma. Then we will replace it with a space. Okay. Comma text. Okay, so this is the rule for removing punctuations. Okay, punctuations. So from there, we can return text. All right. So this is our function. We will try to print at every point to see what is the result. After we do a lowercase, then you can do a print over here to see what is the result of each line if you are curious. If not, you just leave it as it is. Okay, so I'm going to comment this first to make sure there's no issue on the function. Okay, that's fine. Okay, now after we settle with this function, then we call the function to do cleaning. Right, where do we want to clean? So we go back to here. We only want to clean the review. Don't clean the sentiment label. That's ridiculous. This is the one that you want to clean, the review one. Okay, so because the sentiment label is the labels already given by a reviewer that after they read this. So we want to prepare the data set so that our AI model can understand this data set better. So we hide this first and go back down here. So which means that, going back here up again, forgot to explain, which means that we want to look at this column called review. Don't call the column called sentiment. So we're going to call that through our data frame. Okay, so we're going to apply the cleaning. So it's good to actually build another column based on the data frame format called clean review, so that you don't mix the one original with the cleaned data frame. Okay, so we call the F again, and this is from the review. Okay, and we want to apply the function that we've already created above, which is called clean text. And that's it. So you don't add the values in the clean text or any parameters inside the clean text. Okay, so run this and it works. Okay, so it's quite fast, only 1,000 plus lines. If you have 50,000, that would take some time. Okay, now let's compare to see the difference between the one from the original, the review one, and then the one, and then the one from the clean review. Okay, forgot to open another bracket because we want to display this as one data frame by combining the first column and the second column. First column is review, second column is clean review. And then we want to see the first 5 rows. So we run this, and then this is our data set that we've already cleaned on the right side. So the left side is the one original, the right side is the one after we clean it. So you will see that some words are being removed, and we already see that the HTML tags are being removed definitely. So, and we see that there's no punctuations anymore, there's no comma, there's no full stop. So that's good. So we just want to have this sentence to be to be modeled in the AI for sentiment classification later. Okay, so the rest are the same as well. Okay, so this for me on the right side is clean. For some people see that, oh, this is not, we can't really understand. That's fine, but the AI understands the context over here on the right side. The one on the left is very dirty. It's not ready for AI modeling, especially for sentiment classification. Maybe for other things you can use it, but not for sentiment classification. So the moral of the story is you need to read how to do your AI modeling. What are the requirements needed to do your AI modeling? Do you need lowercase? Do you need to have all uppercase? Or do you need to do some transformation? Okay. So those are the outputs that you can see over here. I'm only on hands-on 2 and it's already 140. Never mind. Okay, so that is up to the cleaning. But maybe you want to also see what happens when you do this step by step in this function. Okay, it's good to do some printing of each line to see what happens. Okay, so let's say you want to see what happens when you run this one. How come it's not printing? That's funny. Should be printing. Maybe I should run this step. Yeah, correct. Okay. So this is the output after you change it into lowercase. Yeah, after you change it to a lowercase. But it's not complete yet because we have punctuation problem, you have HTML text problem. So you can print other, you can test this to see what happens after you do the cleaning step by step. Another one that I want you to try is also to mix around this the sequence. Maybe you want to do the lowercase later, maybe you want to remove the HTML text first, and you will see that if your sequence is not correct, you might get an output that you do not want. So I want you to try to mix around these steps. So it's very important on the steps on how you do cleaning, which one you want to do first. Change to lowercase first, or you want to remove the punctuations first, or you want to apply the beautiful soup first to remove the HTML text. This sequence is very important and you need to check whether you did it correctly and whether that is what you want. Because I've seen my students did it wrongly and then the sentence doesn't make sense. After they clean it up, it's too clean until the context is horrible. Okay, so this is what you need to be prepared when you are doing some cleaning. Okay, so I'm going to run that so that we don't... Oh, that's funny. Okay, I need to run this again. Okay, so that's what I want. Okay, hide this first. All right, so going back to here, so we've done cleaning. Now let's look a little bit about feature engineering. So feature engineering is good to be done because you want to remove duplicates, you want to remove you want to extract important features before you start to use that data for AI modeling. So I'm giving this an idea so that you will see that having two fish, it doesn't mean anything. It's just the same representation of the fish, it's the same color, it's the same bike, and etc. But you need to keep at least one of the feature. Maybe let's say this, I think this is a rubbish. That rubbish is important. So you need to keep it. You cannot remove it. So because his feature or her feature is important in the model, then you need to keep it. Any duplicates, you need to remove it. Okay. All right. So maybe I explained a little bit on feature engineering. Maybe tak sempat to work on all of it, but we'll go into this a little bit later. So feature engineering is the process of transforming raw data into meaningful features. And what we're going to do is do some, maybe a little bit on text cleaning again, advanced cleaning, which is removing the duplicates, and apply lemmatization. So lemmatization is one of the important feature engineering transformation needed for sentiment classification. sometimes other data needs to do stemming as well. So that is another natural language processing needs to be done on the data set. And the one that I want to emphasize in the text transformation into TF-IDF transformation. So let's go into this part. Okay, let's do a little bit on the removing the duplicates. Maybe I need another hour. Is that okay? Anyone ada dating kah selepas ni? Maybe half an hour. Is that fine? Half an hour? Okay. Boleh? Only one person says okay. Half an hour. Okay. So let's look into removing duplicates. Okay, so but first we need to see. Muhammad Faris says cannot. You got class or you have meeting with supervisor? Okay, tell your supervisor half an hour late. Sekejap je, setengah jam je. Sekejap je. Okay, so let's look into this one first. We need to know whether we have duplicates or not. Okay, we need to know whether we have duplicates or not. So let's look into that. Number 3. Okay, so let's say we are looking at the clean review. So let's say we want to add you want to create a new data frame to combine the clean review with the sentiment labels that you have right now. So we call DDF, I call it DDF now. You can call it differently. So DDF equals to DF, which is the original data frame tadi. And then we want to combine together with the clean review and the sentiment. Oops, the sentiment. So run this and oh yeah, I forgot. Okay. We need to print that out. Yeah, ddf.head, print that first 5 row. So this is the left side that we have the clean review, and then this is the positive label. You put it together. So what you want to do next is to see how many duplicates that we have in this data set. So we can use this function in the data frame. So this is your data frame tadi, DDF, and we use duplicated. So duplicated, and we want to see how many. So we use the another submodule under under data frame. So it is called sum. So run this, see whether we have some output. Here we say, it says 96. So if you want to print it properly pun boleh, then print it out. I call this as duplicates equals. All this as duplicates. I forgot the curly brace. It's important. Okay, I have to. Right. Let me try to copy this. Try to do something different. Run this. That's odd. Duplicated dot sum. Oh. Right. Suppose in the brace, in the bracket, not bracket, in the code. Run that. Okay, so I can run duplicates inside. Okay, so you can call your variable inside that. This curly brace is there if you have this F. Okay, right. So we have 96 duplicates. Oh, okay, so you can open up your CSV and see whether you can find the duplicates. But if you don't want, okay, fine, you understand that there's a duplicate. So we need to remove these duplicates, okay? So how you can remove this? It's very easy. There's a one-line code to be used. So we call our data frame again, DDF, and then we instruct that this DDF data frame to drop the duplicates. So we use drop duplicates just like that. And immediately you can recheck again how many duplicates you have back. Let's say you run this again to see whether you have duplicates anymore. So don't have any more duplicates. So it's very easy to just remove the duplicates. So sometimes when you have a huge data set, thousands of lines, then maybe this is one of the ways to process your data to remove the duplicates. Okay, so this is hands-on 3. So this is a sample output. Let's say you have some other data sets and it will show you how many duplicates you have. Then after cleaning, you need to check back whether you have already removed the duplicates or not. Okay, so next is to do lemmatization in this data set. Okay, so why do we perform lemmatization? Because it helps to reduce the vocabulary size while preserving the meaning. Because sentiment classification really it really looks into the context, because from the context we understand the meaning. So if you look over here, this is the sample output before you clean the review data. And then after lemmatization, it looks the same for the first line because each of these words can bring, how to say, cannot be lemmatized anymore because it is from the original form. Okay, we do lemmatization because we want to find the root word. For example, we have the word hated here. Then after we lemmatize, we only keep the word hate, the origin of the word hated. So if you look at the right side, the meaning doesn't change. Hate film boring long. So the context is the same as hated film boring long. It's just that the method is a past tense. So but the context is still the same. Okay, so let's try to do this lemmatization. Okay. So lemmatization, we need to import from NLTK. So from NLTK, under stem, we can import WordNet, and under WordNet, there is a lemmatizer. Spelling. NLTK. Okay. So from there, we download the WordNet. So WordNet is a collection of words and with the nets itself, and it has been used for many things. When we want to process data, we want to understand data or visualize data, textual data most of the time. NLTK. Keep on doing NTLK. Okay, so do these ones as well. So you move it away from other cells. So from there, besides that, there are various versions of WordNet. You can check out what versions WordNet available under NLTK. But for this purpose, we only use the original version of the WordNet. Okay. Okay, so let's say we call lemmatizer as our variable to run the WordNet lemmatizer. Okay, but this is just to initiate it. So we need to, let's try to come up with a function okay, define our function to lemmatize our inputs. The inputs here will be the text from the dataset, the IMDb dataset. So let's define our lemmatizer function. And the input will be the text. Okay. All right. So let's say we call this as a new text as an array. We set this as an empty array because we're going to add the new, the lemmatized text into this array. Okay, so we set this as an empty array. So now we're going to read all of the words in the text. So the text here will be the whole review that is inserted into this function, and then we will read word by word. So for word in text dot split, so we will lemmatize that word. So we call this as another variable. So lemmatized word. Then we will call our lemmatizer, which is the one at the top here, to lemmatize that word. And we need to call the sub-function lemmatize from wordnet lemmatizer. Kind of confusing, but there are so many sub-modules, so we have to follow up as it is. So once we lemmatize the word, then we put back into the text data. So we need to join it back again. But first we have to put it into our array. Okay, we can append that. We use the append function to add into our array. Do not use new text equals to lemmatized word because it will keep on substituting the variables, so it's not a good idea. So append it. Okay, you should know how to use array function. Okay, when it comes to arrays, you need to append the array function by adding new entries. Okay, so once you append that, so all the lemmatized words is added into the array. So you need to join back all the words so that you will have the whole text data back, because these are all the lemmatized words added into the array, and it is not in a sentence level or a paragraph level yet. So you need to join it back again. So that is why we need to use the join function. So I'm going to do a new to_text variable. And here we will join the words with a space. So we use the join function. And we call that as and we call the array as it is. Okay, array just now is new_text. Then we return new to_text. Okay, so run that, no issue. Now we need to do the lemmatization. So we apply the lemmatization on the clean review. So we maybe we call our data frame again. We call a new column for lemmatized review _review. Okay, and this data frame will include the lemmatized reviews from the clean review. So don't take the original review tadi because we already cleaned the review. So we follow by the cleaned review. So dot apply. So we only focus on that column. So we call our function lematize_text. Okay, hopefully there's no issue. Let's run it. So it takes some time because lemmatization takes quite a while to do. Okay, now we try to print the outputs. So we put back these two columns together to see the difference. First, the clean review. To open another bracket here versus the lemmatized review. And we want to see the first row, the first 5 rows. Okay, so now we have the clean review versus the lemmatized review. It looks the same, but if you look carefully, maybe some parts, okay, some parts are not being lemmatized correctly by WordNet. Like for example, over here, maybe you see hearted is the same, and maybe but if you see reviewers on the left side on the clean review, it becomes reviewer. So it is being lemmatized to the original word. It doesn't care about plural. Okay, so but there are some things that maybe are not that perfect because it really depends on the WordNet database. So if you have full lemmatized words in the WordNet, so we have better results. But we use whatever it is given to us. Okay, so yeah, so this is the lemmatized review on the right side. Okay, now let's try to replace. So we replace the lemmatized review with the clean review and then add it together with the sentiment labels that we have. So we will call DDFF. So it's a different data frame already. So DDFF contains DDF. And this contains first the lemmatized review and then followed by the sentiment. Then we want to print it out to see the first 5 rows. Okay, so now we have our lemmatized review followed by our sentiment labels. Okay, so this is our so-called very clean data, which now we want to further use for extracting features. Okay, so we have one more step, which is to do feature engineering on the data set to transform it to get our TF-IDF. So that's the next step. So what is TF-IDF? TF-IDF, it means term frequency inverse document frequency. And what is term frequency? It shows how often a word appears in a document. And IDF is looking at how unique the word is across all documents. So to calculate TF-IDF, there is a formula, but we're not going to do it explicitly. So we're going to use some functions available on Python for us to obtain the TF-IDF features. Okay, so how does it help in machine learning? Because it converts the text data into numerical values, and AI models normally they will process the training based on training the features. They don't explicitly train on the text data because text data takes a lot of there are a lot of bits, and the size of the training data might be huge if we train directly on the text data. That is why we need to do feature engineering for us to extract the important features and only represent the important values that can be understood by the AI model. So and also it helps the machine learning models understand the importance of the words in a data set, because TF-IDF looks at how often a word appears in a document. So you can look at the frequency of a certain words in a document. Less frequent words being used in the document is not really important at times. So that's why maybe that word may not be interesting for us to use to train a sentiment model. Okay, so TF-IDF also helps to measure the originality of a word by comparing the number of times a word appears in a document with the number of documents in which word appears. It sounds confusing. I let you to understand it more. Okay, so let's look into TF-IDF transformation in Python. We use scikit-learn library. So scikit-learn contains a lot of machine learning models. but I would say they are more classical approaches, which is good if you want to learn about machine learning. I don't think, I might be wrong, but maybe no deep learning models are available in the scikit-learn, but it's a good library to use if you want to start with simple machine learning modeling. Okay, so it is one of the most powerful and also useful machine learning libraries. It has many modules. First, we can use it to extract features like TF-IDF. It can also help you to do data pre-processing. For example, it can help you to split the data for training and also testing. And also, there are many machine learning models supported. We can go through this in the later stage of our course. And then it provides evaluation metrics for you to evaluate whether your model, to show its accuracy. Okay, so what would be the best practice? Always import what you need only. For example, if you want to do feature extraction, just import this sklearn.featureextraction.text and then import the TF-IDF vectorizer. If you want to do modeling, then if you want to do train test split, which means splitting the training and also the testing, then you can use sklearn.model_selection, import train_test_split. We will do this later. Okay, so but this is the best practice to use the sklearn. Okay, so this is the hands-on 5 whereby we want to transform the IMDb dataset to transform the data into TF-IDF. So this is a sample output you see on the right side. So for us, we don't really understand what this means, but if, for example, in an NLP researcher, they would see, okay, this is only a sub of the output. It's not all. This, the one at the top here, we have the index able, absolutely, across, acting. Able, absolutely, across, acting are the words extracted from the data set. And each of the words, it has its probability. It doesn't mean on the first column able, it doesn't mean that the able is not being used. If you look at the index 0 means the first review. Index 1, the second review. Index 2, the third review. So maybe at the third review, the word able is not being used. The word absolutely is not being used. But for index 1, which is the second review, the word actor is being used and the probability of this word appearing in this document is 0.11. Probability is the measurement being used in TF-IDF. Okay, so how to understand the output? Higher TF-IDF values indicate important words for specific review. And if you see the word amazing, maybe you found the word amazing in this data, this can give some indicator there are some sentiments being provided in the review. Okay, so if you have sentiment data sets that have these words, worst, amazing, good, happy, etc., and they have higher scores, which means these are sentiment driven words. So review data normally gives this kind of words lah. Okay, so these are the things that we want to do. So please give me another 15 minutes before you go dating or etc. Okay, so let's go into hands-on 5. Okay, so let's continue from our data frame lemmatized review because that's the clean one, and we're going to do this part 5, which is TF-IDF transformation. Okay, so we will import from sklearn. You may need to also do a pip install if this sklearn is not available in your machine. Yeah. So this is already in the Google Workspace. Extraction.text import TF-IDF vectorizer. We're not gonna do transformer, just the vectorizer. Run this and hope it works. It does. So next is to initialize our vectorizer. Okay, so how to initialize? There are some parameters needed, but I'm going to just demonstrate only one, which is we want to fix the number of maximum number of features to be added into the model. So TF-IDF is a model, but it's not equivalent as an AI model per se. It's a like a mathematical model. Okay, not all mathematical models are AI models. So we want to build our model like interpolation models. So it's not AI. Okay. Okay. So we set our features to be just 500 first, which means we only consider the most important 500 words in the document, in the data set. Okay, so we initialize that, and then now let's try to apply TF-IDF. So first it will initialize, and then it will apply TF-IDF to transform the data. Okay, so it will be in a matrix form. Oops, TF-IDF underscore matrix. So equivalent to calling the TF-IDF, okay, and then we want to feed it to the data. So we call feed underscore transform, which is available under TF-IDF module. Then what we want to feed to the lemmatized review. So we will call DDFF data frame, and then call the lemmatized review. Don't do the sentiment, doesn't make sense. Okay, now let's try to see what we have on the TF-IDF matrix. Okay, run this, and then let's see the output. So these are the outputs that we can get. On the left side, you will see that the coordinates of the matrix, the index of the matrix, like ij. So at the position of I equals to 0 and j equals to 306, we have some values. So it represents some values. If it doesn't represent values, which means that at that particular point, at that particular index of that matrix will be 0. So these are the only values that you have. So let's try to put it into data frame so that we can also see it in the context of words, like the one that I show over here. Okay, so we can do add the matrix into the data frame. Okay, so combining the TF-IDF with the data frame, TF-IDF underscore data frame. I just put it as DF. Okay, so we call our Panda just now, and then building another data frame of TF-IDF transform matrix. Okay, so we bring our TF-IDF matrix, and then we need to convert this into an array. So this is one of the functions available in TF-IDF. Okay, and we need to call that bracket there because actually we can insert some parameters. So there are some suggestions there, but we're not going to do that yet. And at the column wise, we will try to get the names of, not the names, but the labels, the words in the text data. Okay, so columns equals to TF-IDF dot get underscore feature names. This is the one I want to use. Okay, feature names out, and we have that bracket. Okay, then let's try to display this data frame. So this is basically a new data frame, but it does not have the sentiment label. It does not have the lemmatized review. It is a combination of the matrix from the TF-IDF and the features that has been extracted, and we want to display the name, not the names, but the words that are given the probabilities. Okay, so TF-IDF underscore DF, and then let's see the first 5 rows. You run this, and this is the probability that you see. There are many zeros, but it doesn't mean that these are all zeros. Okay, you have to open it up. Maybe you can generate up to 10 and see how it goes. Okay, so there's data sparsity that's normal. Okay, so maybe this is clearer once you see the interactive matrix over here. So you will see that at some point on review number 5, okay, the 5th review, you will see that there's a word acting with the probability of 0.079. So this is the probability of this word against all the documents. All right. So you don't have to go through this, but this is basically how you can obtain the features based on TF-IDF extraction, right? So that is how we can try to use this data to extract our TF-IDF, and later on you will use this TF-IDF to train your model. Okay, so let's look at hands-on 6. I think this is related to enhancing the TF-IDF feature engineering. Here you can actually play around with the maximum number of features, which is over here. Initially, we set this to 500. See if we, let's say we set it to 1000 number of features. So we will get the most prominent 1000 features into our matrix. So we close that and see whether we have some difference on this data set. So you will see that there are some differences in the context of the probability. Okay, because now we add more features. Adding more features doesn't mean that the TF-IDF fitting to the model is good. Sometimes reducing the features will be better. So these are the kinds of sensitivity analysis that you can actually conduct when you want to generate different models based on different number of features in the TF-IDF. You want to get the most optimized model. Maybe you can learn from generating the right amount of TF-IDF in terms of the features. Then you train a model. Then you see the output. So these are the things that researchers do or developers do. They try to find ways on how to optimize a model. Because sometimes adding new data is not necessary all the time when you want to improve the model. It's not always the rule of thumb. People say that adding new data will give you better model. It doesn't mean that way. Having bigger model in terms of size will give you a good model. It doesn't work that way as well. So optimization has many methods. Then you have to do some research out of this. Okay, so sometimes developers, they try not to care about optimization, but for researchers, they do. They want to see what are the techniques needed to optimize. Okay, right. So for hands-on 7, I think I will do this because I think that's the only one left. Just one more, which is related to visualizing the top n important words. Okay, so in doing this, because we want to visualize, you can use the Seaborn. I think we've done this already before. Okay, so using Seaborn, and of course, to use Seaborn, you need to use the matplotlib. Okay, and I think I'm going to use the pyplot. So let's try to get the top 20 words from the TF-IDF. So this can be done as a part of your analysis on the data set that you have. Okay, you want to understand what will be the top 20 words from your data set. So you can't really just dump your data set and then, oh, okay, voila, I'm going to get the top words. It's best if you can use the features and get the top words. Okay. So to get the top words, okay, I call top words equals to, over here, I'm going to use the min function available in the TF-IDF, TF-IDF dot TF-IDF underscore DF, which is the data frame that we have just now. And then I'm going to call the min, and then I will call another sub function called sort, because I want to sort based on descending order, which means from the top to the bottom. The top one would be the most frequent words being used in the data set. So we will sort the values, and then over here I'm going to let the ascending to be false. I don't want it to be in ascending order. Okay. And yeah, and then I'm going to display the first 5 rows. See what we have over here. Oh, I should put this in another cell. That's odd. Is it not printing? Okay, maybe I need to do it this way instead. Print. Okay, because I keep it as a variable. All right. So we will print this. Now we have the first 20 words. Okay, the first 20 words, the top 20 words in the data set with the probabilities. So the probabilities are not really that high. Well, that's fine. We don't really matter about that because it really depends on the data set that you have. Okay, so these are the top 20 words. Right, so let's say we want to display them in a bar plot, for example. Let's try to plot the top words. Yeah, this is not necessary, but I'm gonna do this bigger size to be 5. I'm going to use SNS bar plot. So X will be the top words, and we're going to only display the indexes, which means the words itself. And then Y will be also using the top words, but it will be measured based on the words. Measured based on the values. So the values here are the probabilities. Okay, and let me try just to do a plot show. Okay, so here we visualize the top 20 words. Okay, you can continue by labeling the chart with the chart title, with the x-axis and y-axis labels, etc. So I just want to be fast, so you can actually display the top words, the top 20 words. You can also generate, for example, word cloud. So from Python, you can generate a word cloud using word cloud module. Okay, so we need to import the submodule over here with cloud. Yeah. So for this one, we can use the values from the this one is based on I think I'm not using the TF-IDF per se, but I'm using the lemmatized review to build the word cloud. Maybe next time I will show you how to use the TF-IDF to build the word cloud. Now I'm just using the data set itself. So call the word cloud, and here we can set the width, the height, other things, but let's stick to that first. Generate using the lemmatized review. So we use a join function, and we will call the lemmatized review column. Okay, let me try to run this first. Right, so word cloud is there already. So next we want to plot that. I'm going to copy this one. We need to set the size, and we need to also initiate the word cloud. It's called plt.imshow. So we're going to use the word cloud that we've already generated there, and we will set the interpolation type. So this one is important somehow. We want to use the word cloud. I will use bilinear. There are many ways actually on this part. Okay, so I'm just going to do the show. There are many ways on how to make this word cloud more interesting. Okay, so the background is black. So maybe I will change this to background color. Yes. This was. Okay. So this is your word cloud. For this case, I'm using the lemmatized review to generate your word cloud. I should have used the TF-IDF just now. I'll do that next time. But yeah, this is the word cloud for the whole of the data set. Just now we show that based on our TF-IDF measurement, we found out that movie is the most used word. And from the word cloud itself, even though we're not using the TF-IDF, we are using the lemmatized review. We found out that movie is the most frequent word as well, based on this word cloud. The bigger the word in the word cloud, the more frequent that word is being used. So yeah, so it seems like correlation is there lah, okay, from the TF-IDF perspective, and also by generating the word cloud in this context. Okay, so yeah, so this completes our practical 2. So there are some takeaways over here, and also there's something that I want you to actually practice for exercise 2. Yeah, before we complete that part, wrapping up to this practical is that it is very important to do data cleaning, because it really can impact the performance of your machine learning model, especially when you are dealing with textual data. I'm pretty sure when you deal with other kinds of data set which is not textual, you still need to do some data cleaning, data understanding, and also data transformation. Okay. All right, so going back to the pipeline that I showed before, what we are doing just now is the data cleaning and pre-processing. And we also do some exploratory data analysis, where you try to analyze the data frequency, generate word clouds, and maybe also display the data distribution. I think this one I have not really gone into this case. You can explore that on how to show how many sentiment labels that are related to positive, negative. If they are also neutral, you can also try to display that. You can work on the second column to do that. Okay, second column of the data set. The other one that we did just now is feature engineering, where we perform this transformation as needed by a machine learning model. So there are many feature engineering ways, not only TF-IDF. We can also extract word embeddings. If we're dealing with speech processing, speech recognition models, we have to extract the melt frequency substrate coefficients. So that is a part of feature extraction method before we go into acoustic modeling. So yeah, from there, all this data understanding, the next step is that we need to do is machine learning or deep learning modeling. So that we'll be doing in the latest chapter of this course. Okay, so with that, so this is the second exercise. I have another data set. We have so many data sets that you can actually get from ELIT. You can also get this data set from Kaggle. I provide the link for you. It's actually a text classification data set, which also has the sentiment labels. And it has two data, one train and one test. They did it explicitly and divided into two, maybe easy for data manipulation, data analysis, and etc. So I want you to only process the test data set because it's smaller. And then I want you to try to perform data cleaning on the tweets, then apply the same techniques to clean the train data set, then perform feature engineering to prepare and also analyze the data for machine learning. Then after that, yeah, maybe be ready for the next one, which means coming up with the sentiment modeling. But this is only for the test data. Once you feel your test data is clean enough, you can use the same technique on the train data set. So this is what I want you to do. You don't have to submit your PYNB notebook next week. You just do it, and then if you need us to discuss, we can discuss that. Okay, but it's best if you can actually show me what you have done. Okay, so that's exercise 2. Any questions before we complete? All right, in your ELIT course page, sebelum you tanya lah juga, your assignment 1 is already out. Yeah, okay, Paris, if you already gone, I can take your attendance later. Okay. Sekejap. Okay, yeah, the corona dataset is here. You can download that. And if you look at your assessment, this is individual assignment lah, huh? So individual assignment is already here. So this is the first one. This is the notebook that I want you to complete. The question is here. And submit your challenge over here. Question is this one. Basically, it covers practical 1 and 2. Consists of 7%. So next week, we will not have any class. We have Hari Raya. Okay, selamat Hari Raya kepada mereka yang menyambut Hari Raya. And have a good break for those who are not celebrating. But Thursday, we were supposed to have class with Prof. Jane, but she decided not to have class on that day. So I want you to do this assignment 1 quickly so that you can submit it as soon as possible. So you have some mission over here. So you do this as a challenge. I want you to challenge yourself to clean this data set and to try to understand the data set and try to discover some important or interesting insights that you can see from this kind of data set. So this data set, you can download it in the list of data sets available over here as well. We have the emperors with missing data. So I want you to process the data set and come up with a complete data set. Okay, so from a data set with missing data, I want you to submit a complete version of the data set. So you must have some strategy on how you want to complete the data set. There are a lot of missing data set available over there. Then try to understand the data by, I don't know, whatever ways you can try to understand computationally, not manually. Okay, and number 7 here, I would like to emphasize that do allow you to use AI, up to you, but you have to justify why you want to use AI in this case. Because why you are final year students, at the end of the day, when you go out, you'll be using AI, and maybe at some point you will be doing AI modeling as well. It's okay. For me, that's fine. But I want you to understand why you want to use this AI tool to help you to do programming, because you're supposed to know already this program and you should be better than me. So how do you use this in context of learning? I want you to justify that and put it into your IPYNB notebook. Okay? All right. Any questions? No questions, huh? Okay, wait on. Let me generate your attendance. Okay, thanks, Rebecca. Try to. Oh no. Okay, give me some time. I need to regenerate the attendance sheet for you to scan. All right, you can scan your attendance. So the next time you meet us will be after Raya. There will be a physical class. Please know where your lab will be. I think that's available in the elite course page. Okay. If you have any questions related to the practical, you have any questions related to Python notebook, please you can email me. Okay. Don't worry about that. Yes, the IMDb dataset, you can refer to the Microsoft Teams under files or folders. I can remember files. There are data sets available in there. So the full data set is there. It's quite big, so I have difficulty to upload it into the elite course page. So the full data set for the IMDb, the real IMDb data set, is available in the Microsoft Teams. Okay, thank you so much. See you in the next class. Not the next class, when I see you. Okay, the next class I think you have with Prof. Jane. Yep, thank you.